Hello, this is MEI Further Maths Core Pure. We're in the fourth Matrices section and on the second video on solving three simultaneous equations with a unique solution. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. We've already found that our knowledge of matrices gives us a really neat way of solving a pair of simultaneous equations. But the really big advantage of this method is that it can be extended to solving a set of n equations in n variables. Three simultaneous equations and three unknowns can be represented in matrix form using a 3 by 3 matrix. So you can use the same method to solve multiple simultaneous equations if you can find the inverse of the matrix. For the AS exam, you are not expected to find the inverse of a 3 by 3 matrix by hand, but you are expected to have a calculator that will do it and to know how to find the inverse on the calculator. So here's how to solve three simultaneous equations with a calculator. Pause the video for a moment while you rewrite this set of equations as a single matrix equation. OK, what you get is 3, 2, 1, 5, 3, minus 4, 1, 1, 4, multiplied by x, y, z equals 2, 1, 5. If we call this matrix A, then our solution will be x, y, z equals A inverse multiplied by 2, 1, 5. So now you need to enter these two matrices into your calculator. First of all the matrix A, then the matrix B, which is the column matrix of the right-hand side of the equation. Then you need to get your calculator to find the inverse of A. You may need to look at the instructions for your particular model for this, but a hint which may work for your calculator is to use the x to the minus 1 button and not the to the power minus 1. If in doubt, consult the instructions that come with your calculator. Anyway, once you've got these two matrices in your calculator, you simply do matrix A inverse multiplied by matrix B and get the answer minus 15, 24, minus 1. And now you can simply write down your solution. X equals minus 15, y equals 24, and z equals minus 1. It's always a good idea, as with solving a pair of simultaneous equations, to substitute your solution into all three equations and make sure that they work. When we were working with two simultaneous equations, we looked at it geometrically in 2D space. For a set of three equations, they may be regarded as the equations of three planes in 3D space. OK, here I have my three planes, and you can see that they intersect at a single point, so that we do have a unique solution. In the next video, we'll be looking at what happens if the intersection of the three planes is not a single point. You might like to investigate that with 3 pieces of card before watching the next video. There are more notes on integral or in your textbook on solving three simultaneous equations with a unique solution. That's the end of this short video. The next video in this series is on solving three simultaneous equations without a unique solution.